Alright, the purpose of this is for me to go through what you can expect to see on the final for Chem 2211. Now what you can look at here is a sample test for the final, and you can see that we have 3 questions over aromatics. They're from test 1. You've got 3 questions from test 2, and these are aldehydes and ketones, or formation of aldehydes and ketones. And these are carboxylic acid derivatives, or carboxylic acid. You can expect to see those from test 3, and then here there's 1 question from test 4. So that's 3 from test 1, 3 from test 2, 3 from test 3, and 1 from test 4. And of course your next question is going to be, are the reactions going to come directly from the tests? And the answer is mostly. I cannot guarantee that every reaction on the final will come from the tests that you took, but I'd say that if you studied your tests, that would go a long way to being in the right ballpark for the kinds of problems you can expect to see on the final. I think that if it was me, I would study all of the test 1 questions on all the old tests. Sorry, all of the question 1s on all the old tests, and that would give me a pretty good feeling that I was on the right track as far as picking up questions for the final. Alright, so that's question 1. Let's take a look now at question 2. Now to do this, I'll take a look at I want you to take a look at this screen here. These were the mechanisms that were but I wanted you to know for test 2, and those were formation of a cyclic acetal, hydration of a cyclic acetal, the addition-elimination of a primary amine to an aldehyde or ketone, and the addition-elimination of a secondary amine to an aldehyde or ketone. So those were all the possibilities for mechanisms in test 2, and those will be the same possibilities that you should expect for question 2. That is this question on the final. So those 4 would be possibilities for that particular question. Question 3, I would be expecting a question that matched the acidic type mechanistic pattern, the one I'm showing here, where Y could be pretty much anything. We're talking about a carboxylic acid derivative here, and then it reacts with something, usually a nucleophile, an H+, where the X replaces the Y, and reacts through this acidic mechanism. You can expect a similar kind of mechanism for question 3 on the final, so something of that ilk. Question 4 will be a combination spectroscopy type question, where you'll be given an infrared, a proton NMR, and a carbon-13 NMR. They're all for the same compound. You are given the molecular formula for that compound as well, and the expectation is that you will find the structure of the compound and then label the peaks as necessary. By doing A's, B's, C's, and D's, or 1s, 2s, 3s, and 4s, by labeling the compound and labeling the peaks, and by labeling the appropriate things on the infrared spectrum as well, like you call this an OH, this would be CH, alkyl stretches, etc., etc. So those are the kinds of things I'd expect to see, as well as labels here. A's, B's, and C's, and labeled compound as well. You'll probably have to end up drawing the compound twice and labeling the compound twice, once for the proton and once for the carbon-13 spectrum. Alright, let's take a look at the next one, question 5. You can expect that to be pretty similar to question 2 from test 1, and I've got that pulled up here. And on the actual test, you'll be given the templates as they're given here. The group that's already on the ring, of course, could vary. It could be activating or deactivating, and you'll have to adjust for resonance structures in these templates accordingly. But in this case, it's activating, but it could be deactivating as well. And I think that's the kind of thing you could expect to see for that question on the final, which would be question 5. Question 6 will be a synthesis question, and that question will be able to be done by using the reactions from question 1 of the final. So of course those reactions are all based on your old tests, and the better you do with those, probably the better you'll do with the synthesis problem as well. Question 7 will be a roadmap problem. I imagine that the roadmap problem will have reactions that are not limited to the ones you see here, but you can see that there's looks to be a bit of an acetoacetic ester synthesis type vibe to it, so there seems to be those reactions from that sequence involved. I'd say that that would be something good to look at for the final as well. It looks like there's a glycine condensation in there. I think that would be good to look at. And then there'll be some other reactions on the roadmap as well that you'll have to be aware of, and I think that your knowledge of question 1 reactions, the kinds of reactions you would study for question 1, will help you a great deal with number 7 as well. But I think I've given you a pretty good starting point as to what you're going to see in the roadmap as well.